You have used some grade 10 math skills, i.e. solving systems of equations, to solve problems throughout this course, i.e. two-body problems in the forces unit. Remember the problems you solved, for instance, involving a pulley and two objects? You are using systems of equations to solve these. You'll have to tap into these skills some more to solve some of the more difficult problems involving the Doppler effect. The slide on the next page shows an example and some of the setup necessary to complete the task. So here's an example. A police car is driving past you with its siren on. The frequency of the siren appears to decrease by 10% as it passes. What speed is the car traveling at if the air temperature is 10 degrees Celsius? So I've listed some of the given required. Temperature is 10 degrees Celsius. And we know the frequency after the fact is 90% of the frequency at the start because it loses 10%. And we know we're looking for the speed of the object. We're assuming you, the observer, are standing still. You also know that the frequency observed is this particular fraction of the frequency emitted. So if we consider this F2 and F1 I've created here, so the F1 is as it goes towards. Okay, so F1 is an observed frequency. And since it's when it's coming towards, this is when we're using minus VO. And we also have after it passes. So after it passes, now the observed frequency is the F2. So this is set up with plus VO because it's going away from of F emitted. So essentially we've created a set of equations that you can use. So we have this relationship, and this one, and this one, that we're going to use to eventually solve for VO. So you have to think about how you can use these in order to end up with an equation that allows you to solve for VO. It will take a bit of work. You will actually have to make some effort, but you can get there. So take this to start, and now you try.